Okay, so those two sides are the same, making this side also 5. So that, let's ignore this. I want it to be a box. Maybe okay. So that when I'm finding the area of a triangle is half of base times height, or base times height divided by 2, which is the way I like to say it. If you don't have this written down and you didn't do anything, you don't have any paper in front of you, I'm about to kick you out of class because you're not going to sit here and do nothing. Okay, so I see the base is 5, the height is 5, fantastic. I multiply them, 5 times 5 divided by 2, 25 divided by 2 is 12.5, and because we're getting ready to take a quiz, and because sometimes I forget, I'm going to remind myself by saying 12.5 square units so that I know what's what. Okay, so you should be in class. Go away. Base times height divided by 2. Okay, base, height, great. When I'm looking at this second triangle, some of you in here might be going, where base? Like maybe I call that the height. Like I don't really see the base because we need to be able to visualize a little bit. If I take this second triangle and I go, and I look at it now, you don't get these? I mean, you will, but not right now. I'm not letting you open it. I can open it. Oh, of course you get one.
Wait, what are they?
Are they the new unit?
Oh. Wait, don't stop.
No, they are. That's on film. What are they? I'm not telling you.
Apparently there's something exciting.
I'm not
excited
telling
for
you.
you being excited.
You see that way up world?
They're not shirts. I wouldn't have thrown shirts behind my desk.
Also, small box. Excuse me.
She's not standing right here. She spent a whole bunch of her own time, and I mean a lot of her own time. You know, we talk about how we brag about you guys. She entered what we do into a national competition. There was 4,200
Yeah.
4,200 teachers in Oregon that entered this contest. Proud of what they do, right? Bragging about their kids, what they do, programs they develop, stuff they do, okay? There's only 3 schools for state finalists out of those 4,200. This is the, right there. Of the 4,200, she's one of the 3.
Oh, yeah.
But, bless her for doing that. She didn't write about herself. You're missing the whole point. She wrote about you guys. That's all I have to say. Sorry, didn't mean to interrupt.
Thanks. Yeah, I did write about you guys. Again, I just want you guys, really want you to know, whether you feel it or not, whether you're putting forth the effort or not, you are a part of something very special. And it's sucky when you don't see it. Because everyone else I talk to does see it. That's what Mr. Hirschu was getting at by telling you about that. Okay? Just so you know. Okay? All right, so back to this, though. Yes, you may, Matthew. Back to looking at this. It helps if we turn the triangle, right? If we turn the triangle, now we have a base and a height that we can talk about. Now we have a base and a height we can talk about. Okay? But before we do that, we do recognize it's a 45, 45, 90 right triangle. And hopefully we do recognize, okay, cool. If this is going to be my base and my height up here, base and height, because I flipped it upside down. I wrote them little. And the hypotenuse is 7 times the square root of 2. What's the leg? 7. And what's the mathematical thing I did? Mathematically, what did we do right there? Taylor? Well said. Right? To go backwards, I'm dividing by the square root of 2. In other words, I'm putting 7 root 2 dividing by another root 2. And what happens when I do that, right? Root 2 divided by root 2 cancels each other out. They technically simplify to 1, but you don't really care about technically. Okay, I'm joking. So that the height here is 7, the base here is also 7, and when I go to find the area, I can say base times height, 7 times 7 divided by 2, because it's half of a square. 49 divided by 2, 20, thank you. 24.5 square units. I'm just throwing that in because even if I give you a problem and I forget the units, you don't get to. Okay? Now, remember that whole thing. Backwards, hypotenuse, through the leg. Okay? Hypotenuse to the leg, dividing by the square root of 2. That's what you said last time. So again, let's say the same thing this time. If I know the hypotenuse and I'm working backwards, I do what? I got ahead of myself a little bit, but I'll reverse in a second. Divide by the square root of 2. What would that be? Yeah, like, oh no, I would just call it 10 divided by the square root of 2. Or I might toss that into my calculator because it makes me slightly uncomfortable. Maybe it doesn't. Maybe you're cool with it. And I'd call it 7.07. Now, maybe I got, again, ahead of myself. Some of you might have thought, oh, I'll just do this. And say base and height. And you probably could. But that's a lot harder.
How would you find
That would be half, and it's only half because I saw slaves. You gotta really make sure you're trusting. This is 5, and then... Okay. You could. It's not necessarily correct. But what we are doing instead, again, because here, finding that height would be weird, I'm again gonna think about rotating that triangle. Rotating it until it's poorly drawn. It's close. It's close. Wait, I got it. Wait, make it. I gotta keep going. Does it look flat yet?
There we
it?
go.
Good enough.
So that
Good.
this
Beautiful.
is my base and this is my height. Okay, so there's your base and there's your height. So we're trying to like in our heads a little bit. Okay? Are we all okay? We're spinning a little bit. So when I do base times height divided by 2, again, my base is this weird number, right? And the height is also going to be that weird number, 7.07. So that when I go to find the area of this weird one, I would do 7.07 times another 7.07, base times height divided by 2. Base times height divided by 2. And you get like 24.99. Levi, what? Sam, what?
Is it okay if you're more comfortable with the 10 divided by the square root of 2 and then left it as that, but and filled out how the equation would go, but didn't do it because you can't really do that when it's still 10 divided by the square root of 2?
What'd you give for your answer?
10 divided by the square root of 2 times 10 divided by the square root of 2.
No, you gotta simplify that.
I forgot to simplify.
Okay. So I don't know what it is. What is it? Someone tell me. Answer. Okay, yeah, you should. If you're rounded, you get 24.99. If I do it just like that, so I'll do it just like that. Yes, I know. Yes, if you don't round, it's exactly 25. Yes. If you do round, it's 24.99. I'm cool with either. Okay, are we good with that? We are gonna do 2 things today. One thing. It says right there. I told you. We're gonna do 30, 60, 90s. Then we're gonna do some volume stuff. So in your notes, quick like a bunny. First thing we're gonna do is some G4 stuff. In your notebooks. What up, trig? But you only think of like sine and cosine when you think of trig, huh? Yeah. Trigonometry, the study of triangles. We're going to talk today about the 30, 60, 90 right triangle. I'm going to tell you one thing right now that is very important. If you understand what I'm about to say, then this these are going to be a little easier and you're going to have to memorize less. So if you understand what I'm about to say, the less you have to memorize. Okay. The 30, 60, 90 right triangle, this is the part I want you to understand. The 30, 60, 90 right triangle started as an equilateral triangle. Okay, so it started as an equilateral triangle, so we're going to draw that. Equilateral triangle. Okay, it started, this is my ghost image of the equilateral triangle. Very beautiful triangle, all sides the same, all angles 60 degrees. Who doesn't love that? Okay. Now, if I took that bad mamma jamma and I cut it in half, right? I cut it in half. This is the triangle we're working with, but it is half of the equilateral triangle. It started as an equilateral triangle. And we know with an equilateral triangle, all sides, all angles are the same. What are all the angles of an equilateral triangle? 60. So this would still be 60 because that's the original corner. This up here, is that 60 degrees cut in half? So it's what? 30. Right? Now, first question. Do we know what I'm talking about when I say the short leg? Yeah, this little one, right? And when I say the long leg, what am I talking about?
The long one?
Yeah, the long one, not the hypotenuse. It gets its own special name. So, here's my first question. Supposing, if I call the short leg X, don't say it out loud. If the short leg is X, how long would the hypotenuse be? Don't say it out loud just yet. If the short leg is X, how long then is the hypotenuse? You see X right here? What would the hypotenuse be? Come up with the answer in your groups.
How would you label
Please. I don't know, I just heard the A actually. So. Okay, who says Austin is correct? A few of you. Someone tell me why he's wrong. Major.
There's 3 sides and like, if you like somebody trying to use short, like, someone tries to.
Okay. Okay, Meadow?
2x would be the long leg because the long leg is like the short leg is half of the long leg because it's a lateral triangle. So the hypotenuse would be the x plus 2x. No, x squared plus 2x. Yes.
Austin to defend himself.
Okay, so it started out as a 60, 60, 60 triangle, so all sides are the same, and you still have one original side, and the bottom, the short leg is half, since you cut that side in half, so it would just be half of the longest hypotenuse.
Oh, you agree with him now. Well said then. You persuaded her. Very good. Okay, wait. So what Austin's saying, you still have one original side. It's this. It's actually the hypotenuse is the original length. Okay? And he said, well, this is the original length and the short leg is half of it. Right? The short leg is half this original length. So that if this is x, how long should the whole thing be? 2x. And these two sides would be the same. So that would be 2x or 2 times x. Have we talked about how there's a times in the middle there? Yeah, it's a little invisible thing that people are too lazy to write, just so we're clear. It means times, Malachi. It means times. No, this one. Okay, so the next thing I'm going to talk about. Some of you maybe remember then what the height is. Anyone remember what the height would be? No. Yeah, there'd be an x times root 3. Now I'm going to do two things. I have to, like, there's just something in my soul that says I have to show you this. If I wanted to find the height right now, I want to find the height. What am I going to use? No, like it's a theorem.
Pythagorean theorem.
Yeah, Pythagorean theorem. You guys want this to be A or B?
B.
Cool. That'll be B. I'm gonna cover this up. You don't write B on your paper. Don't write B on yours. You can, but I'm gonna erase that in a second. Just warning you. So that if I wanted to use some Pythagorean theorem, I'm a magician. Okay? If I wanted to use some Pythagorean theorem, I would have x squared plus b squared is equal to that whole thing, 2x, the whole thing squared. Are we okay so far?
Yes.
Okay. Now let's square this guy. X squared is just x squared. B squared, no one cares. 2x times another 2x. 2x times another 2x.
No.
We're missing it. What's x times x? No, x times x.
X squared.
X squared. X times. Hey, quick side note, sidebar. Literal. Let's make it literal. Sidebar over here on the side. Okay. X plus x. What's x plus x? Yeah. X times x is x squared. Just on sidebar. Okay. 2x times 2x then. Anyone want? There it is 4x squared. Now, this to me feels like just magic. It makes me excited. I know, but it's still, magicians are still in awe of their own tricks. Okay, if I'm trying to solve for b, let's remember, I'm trying to solve for b. What do I got to do with this thing? Yeah, I got to move that to the other side. And here's where we need to start paying attention because it's about to get real good. It's going to get real good. Yeah?
Yeah, I know this.
So that goes away. It's going to be so pretty.
And then don't you do it.
What's 4x squared minus x squared?
Wait, what did you say?
If I have 4 apples and I eat 1 apple, I have
3.
cool. If I have 4x squareds and I take 1x squared, I have 3x squareds. Much better. Oh man, so good right now. So good. Okay,
This makes me
so
happy.
good. Do you see the Austin? Do you see the 3? The 3. This when we talk about the root 3, it's right here. It's because 4x squared minus that other x squared, you now have a 3x squared. It's because the hypotenuse is double the short leg. And if I double 2, and I square 2, I get 4. And the difference between those, that's where this 3 comes from. So some of you are going to ask, why is it root 3? Right there, this, right here. That's why. It's gorgeous. To undo a square, of course, I square root both sides. What's the square root of b squared?
0.
B. They undo each other, right? B. What's the square root of x squared? X, because remember, x squared means x times x, right? You go to the dance in pairs. This is 2 x's, x times x, so one of them gets to come out, and then the square root of 3 is sad, and he's still under the square root. Okay, so Austin was right, and if you look in the back of your notes, if you look in the back of your notebook or workbook, you'll see it tells you this. Okay, so that this height right here, always, because we only used x's, is x times the square root of 3. Okay, now, it's okay, I'm just going to also preface with this. Sea level peeps, if that's where you're shooting, I'll talk to you for a second. You don't have to know that. You don't have to know that. You need to know this. You need to you at least got to know how to work between the sides. That's a C. If you're shooting for a B or an A, why? 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 This is why. Okay? No, it's if I want you to know, well, I want everyone to understand. I want all of you to get an A and be master, and all of you to go forth and be math teachers, and that's what I want. But I also have to face reality a little bit, you know? Okay. So,
We'd all be unemployed if we were
no
math
math.
teachers.
Ms. Stolte, if you are a math teacher, how much does math teach you to actually use in your life?
It depends what I did. If I wanted to remodel my house in any way, shape, or form, or do any type of anything with construction, I would probably use it.
Don't they give you layouts?
Do you want to? I mean, sure. You want to just work for someone else? Yeah, go for bare minimum. Good luck. I'm not a bare minimum kind of person, and I don't want you guys to be either.
Once if I ever get roped by someone, I'm gonna think back to trigonometry and use the power of triangles to defeat them.
Yeah, see.
Wait, what do you mean as bare minimum?
If you want the bare minimum out of life, you probably will never use math. Even if you go into carpentry, will you probably do this? Probably not. If you want to be above that, though, if you want to be someone who is, instead of taking orders, is maybe giving orders, instead of working for a company, running your own company,
Like an entrepreneur?
yeah, like if you want to do anything where maybe you better the things around you instead of just sit back and be passive, that's what I mean by bare minimum. Okay, so last thing I'm going to tell you, we're going to point out. Let's talk about some relationships from the small leg, from the short leg to the hypotenuse. What am I doing? Doubling it, which is multiplying by 2, times by 2. If I'm going from the short leg to the long leg, what am I doing?
The same thing.
Times by the square root of 3.
Times by the square root of 3. You'll notice from the hypotenuse to the long leg, any special trick? No. If I want to go from the hypotenuse to the long leg, I can't jump over the top. I've got to go through the short leg. The short legs are a little pivot. Okay? On the 30, 60, 90, everything goes through the short leg. Okay? If I wanted to go backwards, of course, we could do that. 2x backwards. What would I do? Say louder.
Divide by 2.
Divide by 2. And if I want to go backwards this way, what do I do?
Divide by the square root of 3.
Beautiful. Okay? So similar to the 45, 45, 90, just slightly different. We're going to do one example together. One. Solamente. Example. Find the missing sides. Here we go. There you go. You have 30 seconds. Sean, yeah. Shayla, ask her. Just ask her. Yeah, Shayla, check. Yeah. Yeah. Best day ever. You have to use the shortcuts at least once. Because, guess what? If I try to do Pythagorean theorem, if it's like, well, Ms.Stolte, I don't know what you're teaching me, so I'm just going to do something different. And I was like, Pythagorean theorem. A squared plus 7 squared equals C squared. I wish I knew more Spanish. I want to say it, but I can't. You cannot solve an equation with 2 variables. You cannot solve an equation that has 2 missing variables. That is no good. Your money's no good to you. Okay? What I can do is say, hey, maybe Ms.Stolte was talking about all that stuff for a reason. Maybe she was trying to make my life a little easier. Here, what side, short leg, long leg, hypotenuse, which one is this? Short leg, because it's the short one. Okay? To go from the short leg to the hypotenuse, I do what? Times by 2, so my hypotenuse is 14. And some of you here are still a little uncomfortable with the square root of 3. From here, you could absolutely do Pythagorean theorem. You could absolutely do Pythagorean theorem and then simplify your square root. You could. Or you could say, oh, hey, shortcut. If this is my short leg, to go from the short leg to the long leg, what do? Multiply by the square root of 3, so this would be 7 root 3. And here's the work I would show, because some of you guys are like, I don't have to show my work. Yeah, if I want to show my work, I would show times by 2 times by the square root of 3, so I know where you're getting your numbers from.
I don't know how to use the square root thing.
Good, you don't need to. You just leave it like this. I leave it as the exact answer. Ian. Stretching. Cool. Okay, now, let's see how we do. You had this paper from Wednesday. Get it out. Oh, that paper. 30, 60, 90 triangles. Here's the deal. You have 10, 12 minutes. I'm going to give you extra. You have 12 minutes. That means there's not very much time for you to do the, like, one problem, chit-chat, one problem, chit-chat. 12 minutes, I'm asking you to do, go. Boom, 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 boom. Shh. You may work in your teams. You may help each other. I'd encourage you to read the directions because there's not even actually that many problems to do once you read the directions. 12 problems. Ready, set, go. No, listen, listen, listen. Shh. You can fake the funk on 1 and 4. You could say that 4, this should be 18, and this should be 9 root 3. But you do not know that that is a 30, 60, 90 triangle. Based on the information given, we do not know that on 4. Because all we have is a 30-degree angle. And yes, that looks like a 90-degree angle. Okay? Okay? Here's the deal. When we're doing these, measuring doesn't count. Okay? Because, shh. And the reason it doesn't is because there's tiny, tiny error involved. Like errors that we can't even see. Or sometimes errors that we cannot accept. Because there might be an error in our measuring device. There might be a small error with our eyes. There might be a small error with the thickness of this line. And when we're talking about these, we're talking about, okay, something like we're talking about perfect triangles. Like perfect more than you can even think of perfect. Okay, like mathematically perfect, which is the most perfect thing in the world, and I might cry. Okay, so we don't know. You're right, it absolutely is very close, but mathematically, when we're talking about it being perfect, we don't have the marks of perfection, right? It doesn't have that 90-degree mark, and because it doesn't have it, that's it. Conversation is done. Okay? Same thing here. Yes, number 1 does have a 90-degree angle, but we do not know these angles. We do not know them. They are not given to us. Okay, they're not given to us, so we can't do number 1. Number 2 we can do, and here's why. Because we already have these two, and we already have them in the correct relationship, that the hypotenuse is double the short leg. We wouldn't even necessarily have to use the properties of a special right triangle. Because with 2 sides, we could just do old-fashioned Pythagorean theorem. And if we did do old-fashioned Pythagorean theorem, we would still get 3 root 3, which is the same as the shortcut on the 30, 60, 90. Okay? That is the short leg times the square root of 3. Okay? So, on number 3 is probably the trickiest kind of these that you will get. Because it's kind of tricky when I give you the height. Hey, zip. That's the 12. And if I need to go to the short leg, how do I go backwards? This is the hardest one to do. How do I go backwards? Yeah, I wish I would have used orange. I'm sorry I didn't. Divide by the square root of 3. So that the short leg right here, this is 12 divided by the square root of 3. Or in other words, I don't know what that is.
6.9 about.
Yeah, 6.93, let's call it. Yeah, hold on. So that's the half of it, right? This here, this dark bold that I did, would be 6.93 is this little piece right here. This. Okay, so if I want the whole length, what do I have to do with that number? Yeah, double it. Multiply it by 2 so that I get,
13.85.
yeah,
Or 13.86.
cool, 13.86 inches. Okay. All right. Also, B was a little bit tricky. That's the last one I'm going to talk about. 5B, slightly tricky. Some of you might have said that this short side was 12. Check. If you wrote 12 on that short side, you fell for it. I say that nicely. Okay? This is the hypotenuse. It's not the long leg. From the hypotenuse to the short leg, what do I do? Say it loud.
Divide by 3.
No, I don't.
Divide by 2.
What? It's divided by 2, party people. So, it's divided by 2. Because that's the hypotenuse. Because the hypotenuse is double the short leg. And if I divide it by 2, I actually get 12 root 3 divided by 2. Any guesses? Boom! 6 square root 3. So that's 6 square root 3. And then this is the short leg again. Short leg to long leg. What do I do? Times the square root of 3. So here, I might just do that on my calculator. 6 square root 3 times square root 3. Yep, 6 square root 9. And what's the square root of 9? 3. So 6 times 3 is?
8.
Boom. 18. Okay, so we get that answer there of 18. And I wrote 6. Good. Okay. We're going to keep going, but I'm not going to spend a lot more time just trying to drill that into your brains because sometimes time is a good thing. In your notes, we're going to change pace completely. In your notes, new page, brand new stuff. Just swirling your brain around. Not an invitation to talk, though. Sorry. Not sorry. Shh, shh, shh. Volume of prisms. By a hand. Who can tell me what a prism is?
A 3D shape.
By a hand. Mariah? And two what? Wow, a 3D shape that has rectangular sides and congruent bases. There are some words. Do we know what she's saying? Some of you do, some of you don't. Let's go with some drawings. This is, a prism. Is that a prism?
No.
Yeah, that's not a prism. That's a cone. That's not a prism. Is this a prism? Ooh, hold on. I'll tell you what, yeah, this is a prism. And what did you say, Maximus? It's a hexagonal, or Duke wants to say hexagonal. Okay, it's a hexagonal prism. Prisms, quick note, are named for their bases. This is a hexagonal prism because it has hexagon, hexagon, and then stuff. Okay, here we have, what's this then? Eight sides. Octagonal prism, again. Hey, oh, octagon, octagon, prism, right? I like to think of these prisms, I think of them as like a roll of quarters. Take that out. Okay, so you have, basically, if we could think about it, is we have this hexagon, and then there's like a bunch of hexagons. They're stacked up. If I picture it like a roll of hexagon-shaped quarters, I have hexagon, 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 and they're stacked up along here to make up a prism. Same thing here. I have these octagons now, and it's like I took a bunch of octagons and I stacked them on top of each other until I made a prism. Okay? Same thing, right? Here, what would that be called? No, use a prism word. What would it be called? A circular prism, and we know that has a fancy name. It's a cylinder. It's the same thing of like I picture, like stack of pepperonis or something. Okay? So you have these, and they're stacked up on each other. I'm sharing this because I want you to have the same visual, maybe not the pepperonis, but thinking of these as stacks of the base. If I took the base and I put a bunch of them together, okay, it would make a prism. Same thing here. What's this one called? Triangular prism, right? It's like I had this triangle and I stacked a bunch of triangles on top of each other to make a prism. If I'm talking, you shouldn't be. Okay? So, when we're talking about the volume, we're talking about the inside space, right? You've heard about volume. It's all the stuff I could fit into here. And when I'm talking about the volume, I'm thinking about if it's a stack of hexagons, then it's the area of this hexagon stacked up. Which is, what's this really when I turn it like that? This is what? No. On top of the prism, what part of it is it? The height. Put your hand down, please. Okay, so here when I'm talking about the volume, really what I'm saying is if I took all the hexagons and I stacked them all together, that would be the volume. So if I'm looking at this, the volume of any prism, whether it's our hexagonal one, or triangular prism, or octagonal prism, it's the area of their base times the height. That would be the volume. Okay? It's the base area times the height. For every prism. What, Levi?
Well, a hexagon or pentagon or octagon is a two-dimensional shape. And for them to be stacked, they would have to have some kind of thickness.
Cool. Go talk to Mr. Trin after school, okay?
I don't know who that is.
He's a calculus teacher. Also, actuallys are generally kind of, try and keep them to a minimum. Okay. Base area times the height for any prism. Okay, it's the area of the base times the height stacked up. Now we already talked about the idea that this, of course, is that a prism? No, not a prism, because although if it were a prism, let's suppose it were a prism, what kind of prism would it be? A circular prism or a cylinder? So here's my question. Malachi. If this were a cylinder, right, instead of being a cone, if these sides went straight up and then I had another circle right on top right there. If it were a cylinder, don't say it if you know it. That's no fun. It's just arrogant. Okay? My question is, compared to the volume of a cylinder, is this going to be more or less? Less. What fraction of a cylinder would this be? If you know it, don't say it. That's no fun. I'm just asking you what you think. Cool. If you know it, don't say it. Some of us are trying to learn something major. Don't look. Don't. Malachi, did you look already? What do you think? No, don't look! Malachi, guess. Just, yeah, shrug. What? Just guess. You can't be wrong if I ask you to guess. Huh? 2? You think this is twice as big as a cylinder? Huh? Shh, I can't hear him because he's mumbling. You think it's what then? Like 2 of these would fit in a cylinder? So this would be half a cylinder? That's a good guess. That's what I think too. It's not right though. But it's what it makes sense. Shh. It's not half. What? No, Luis, what? What? Do you know? You just want to say because people want to show off? What?
I don't know.
Yeah, whatever. I don't believe you guys. I'm just give it. Who wants to give it away? Just go ahead. It's what?
1/3.
Yeah, it's a third because you can look in your book and that's lame. Okay. This. Hey. For a cone. Yeah, but I'm trying to get going. Thank you for checking though. Don't you worry, I am. Okay, 4, that is not a prism. The volume of a cone or a pyramid is as if you were finding the volume of the entire prism, as if you were doing the base area times the height, but it's only a third of it. The volume is only a third of it. So the volume here would be a third times the base area times the height. Or if you wanted to, you could say it's the base area times the height divided by 3. Not divided by 2 anymore. Maybe because we're in 3 dimensions instead of 2. Maybe. I'm just saying it could be. Okay? So, what I want you guys to do right now, easy, medium, or hard? All right.
Make me cry with your math.
As a hint, if you just draw the 2 bases and then connect them with lines and try and draw 2 congruent shapes. I'm just talking. Jeez, you grumpy McGrumpersons. Hint, that's not a pyramid. Don't get confused. It's a what? Triangular prism. Hold on, last hint. What shape is the base? No, you're right that it's a triangle, but like let's pretend we're an equilateral triangle, which breaks down into 36 and 90. Just trying to help. Just saying, we're combining what we've been learning. What's the height? Cool. You should have got the height as 3√3. Okay? Now, you don't necessarily have to use special right triangles. Thank you. You don't necessarily have to use special right triangles. Because you could have said this was 3, this is 6 in the Pythagorean theorem. But you should have got 3√3 for the height. So that if I'm trying to find the volume, I would find the area of the base first. The area here would be 6 times 3√3 divided by 2. that number times the height. We'll pick up with this tomorrow. Hold up! 97 through 102 are due when? Tomorrow. Please pick up your table